Hey YouTube, this is going to be a little bit of a different video than what I normally do. So the video you're about to watch is one I made, I think like 2 years ago. I think it was June 2020. And what it's about is I programmed an Arduino to run the low-level oil light in my Corvette, in that car there. So I used to have this on my old YouTube channel, and my old channel was deleted by YouTube because of some age verification thing. It wasn't anything to do with the content, but it was some age verification problem where some reason YouTube thought that I was a kid, and I tried to verify my age and they wouldn't accept it, and I disputed it, but they deleted my account and all the content that was on it. So I still had the old video, created a new YouTube channel. I just got to re-edit it together, and then I'll upload it. But I thought it was kind of neat. So if you followed any of my other videos, this one won't quite make sense in the timeline. That's why I wanted to put this little intro to it. This was the car with the old engine, the old gauges, but I still have the video you're about to watch with that oil light and the Arduino. I still have it in there. It still works just like it does in the video, and you'll see. Kind of a cool project. The only change I did make with it is now I'm using an LS3 oil pan that has the temperature sensor float switch. I am not using the temperature sensor portion of that yet, just the float switch part. So this would apply to either a C6 Corvette pan or the float pan sensor, or like an F body. So watch the video, enjoy. I'll try my best to post the code that I wrote for this in the description in the video. I don't know if it's going to let me do that or if it'll show up quite right, but I'll try. All right. Okay, we're going to try this again because last time my camera didn't want to cooperate. Today, hi YouTube, I wanted to make a video, a couple things. If you watched my last video on the LS fan controller, I'm still working on that. I'm just waiting on some parts to come in from China to make a couple good working prototypes. But if you remember, my garage was completely destroyed and it's still not perfect, but now I have a lift. And, which is awesome by the way, and I chopped a hole in my wall and I built a room in the back to store all my crap that was on the floor, which is no longer on the floor. But that's not why I'm making a video today. I'm making a video today to talk about some Arduino programming that I'm going to do on a new project in my Corvette. And I thought this was kind of an interesting, real cheap, simple project. Some of you are aware, this is my 1984 Corvette that's been LS swapped. It's an LS1 with an LS6 cam, 243 heads, and an Elgin 224, 228 cam, all run by a Holley Terminator X. So no forced air, no turbo, nothing like that. There is nitrous coming in its future. I'm going to put the nitrous back on it, but that's not for right now. Right now, I'm just getting the bugs worked out of it and just enjoying the car. And for me, it's the fastest thing I've ever owned as is. So I'm more than tickled with it, right? Well, a couple things that I've had issues, and I'm getting a lot of these little issues ironed out. This is the dash that I put together for the car, and I pulled out the Corvette original digital dash, sold it on eBay for a pile of money, by the way, and I put in just these aftermarket gauges. I have oil pressure and coolant temp are digital, and then battery and fuel. I mean, you get the idea. The speedometer is GPS, the GPS module's up there on the dash. And then I put in these warning lights, and there's everything. There's park, battery, and I made all these bezels. I took it, this is steel, I cut it out, used a high-grade adhesive to bond it to the plastic, and then drilled and put little lights in, turn signals, high beams, all that. And it's just all eBay LED stuff. The problem I run into is with the oil level, because what I did, the oil pan that's in this engine is out of an O2 Camaro. And as you're probably well aware, the O2 Camaros have a float switch in the oil pan to tell the computer when it's low on oil. Not oil pressure, but low on oil level. Now, the GM factory schematic has the wire from that feeding to the PCM, and it doesn't throw a check engine light until it sees that float has been under the oil level for a few seconds. I don't know exactly how long it is, but I know it's more than a second or two. Well, I didn't realize that whenever I put the system in. All I did is I took that float switch, wired a ground through it, and ran that to my LED to turn my LED on if the float switch was there, because I thought it'd be kind of a cool idea. Problem is now it flickers all the time. I'm going to put that clip of that video in so you can see what it does now. Okay, so you can see every time I hit the brake or really get on the accelerator, that thing flickers. Now, some of you are probably saying, well, who cares? Well, you know what? It annoys the crap out of me, so I'm going to fix it. What I'm going to do is take a little Arduino Nano, and an Arduino Nano, a small power supply board, and probably an Omron relay, and put it together in a small enclosure that I'm going to put behind the dash, and make it so that that float switch rather, has to be made for so many seconds before the light will come on. Then I'm going to make it latching to where the only way to shut that light off is to shut the engine off. So even if the float were made again, it's still going to give you a warning that there's a low oil level light. So I just wanted to give kind of an update on what I've kind of been tinkering with. I'm going to get that, probably the program of it hashed out today. And then I'll cut another video in and show you what I came up with here. Okay, so here we're in my basement, and this is my little Arduino development board, I guess you want to call it, that I literally held together with hot glue and zip ties. And I've got a Uno, I think it's a Chinese knockoff of an Uno, but I use this for development. I'm actually going to build a board for the Corvette out of a Nano. And probably this one. I'm probably going to use this guy. I already have wires soldered to it. And I made some mistakes when soldering wires, so that's probably why I'll just cut them off and use this one. But anyway, this is the Uno I use for just developing and writing my code and things. And I've got this little LED strip on here, these LEDs I can make light up. And then I have push buttons here that I can press to simulate whatever I want. And I'm not using the breadboard or that IC that's on there. So here's what I got for a program right now. Remember, we have this issue in that float switch on my oil pan that as I brake hard, that light will flicker on and off. So basically I programmed an on delay timer with a holding circuit into the Arduino. So I have this bottom button here is wired up, simulating my float switch. So if I hold that down for 10 seconds, and I'm holding it now, I just have it set at 10 seconds. I don't know if that's where I'm going to keep it or not. You'll see that the LED will light up. Well, at least I hope it lights up. There we go. You can see it's nice and green, and I release the button, and the light stays on. That way, what would happen is it's acting like a holding circuit. The only way that you're going to make this go off is to power cycle. And I have a reset button over here that I can hit, and that simulates a power cycle on an Arduino, and you can see now it's back off. But if I take this and I just kind of hit it randomly, you know, 1, 2, 3, release, 1, 2, 3, release. So as I'm braking and driving the car, it's not gonna come on, but if I hold that thing down for 10 seconds, now it'll come on, and I'm holding it down now. But so now that I have the program figured out, and if I were better with YouTube, see there it came on. See, if I was better with YouTube, I'd show you the program, you know, how I actually made it. I don't know if I'd be able to put this at the screen and actually show you. I can try. That's pretty rough. Yeah, that's not really working very well. But anyway, if I knew a way to put that image in, I would. I did get this help with this on the Arduino forums. So if you go on there and look up TON timer, or I'm sorry, on delay timer, you'll probably come across the post, and it's been posted on there several times. But this is awesome. So now that I have a development of how I'm going to do this, I'm going to solder together a simple relay, and I have a circuit here in the dry erase that's kind of what I'm going to do. And sorry, my dry erase doesn't erase very well. I was kind of figuring this out. So if I have a float switch on an Arduino and a basic 5-volt DC relay, I can make my 12-volt LED light up. So yeah, I use a dry erase board to figure out my stuff. So anyway, I will make another video and kind of clip it into this one once I get this soldered together in something small that will fit behind my dash. I'm obviously not going to put this big Tupperware lid or whatever the hell this thing is that I've glued stuff together that I use for developing my nerdy stuff. I'm not going to put this behind my dash. You know, so once I get it something small, compact, something I can actually work with and get a program in it, I'll put it in this video. Alright, so this is what I came up with, and I know it looks like an absolute hot mess, and it'll still look like a hot mess whenever I'm done with it. I'm not going to sit here and lie to you and say, oh, wait till you see the finished product. No, it's going to look like garbage, but that's okay. It can go ahead and look like garbage. So what I have is I found a box. This is just an enclosure. I think I bought 18650 lithium cells from made of the finest Chinesium alloy. And they came in this plastic enclosure, and I just kind of ground it out with a Dremel to fit. Now I have this on a knockoff Arduino Nano right here, and the problem with those is the voltage regulation circuit that's in them isn't that great, not for automotive voltage anyway. It'll never hold up. They claim it has a maximum input voltage of 12 volts. The problem with that is any voltage over 5 volts, it has to dissipate that extra voltage in the form of heat. So when you actually feed it 12 volts and then you use any of the outputs to drive anything, it builds that much more heat. So you're way better off to use one of these. This chip here is kind of the guts of like a USB charger in a phone. I bought this off eBay just in these little chips. All it is a simple board. You put 12 volts DC in, it puts 5 volts DC out. It's just a voltage regulator. I think you can feed them up to 24 volts maybe. I don't really remember. They're like $1 a piece. They're dirt cheap. I've used them in lots of Arduino projects. They're super small. They work really well. So I have 12 volts DC coming into this. That'll be from this orange and blue wire. Then the 5 volts comes out and feeds the Nano, and then this ball of tape over here, right here, is actually a chopped up relay. Let me see if I can find the rest of it. No, I don't know what I did with it right now. Anyway, I had one of these. Yeah, I do got one. Sorry. I had one of these 4-channel relay cards. These are optically isolated relay cards. And I wired it wrong because I just, quite frankly, wasn't paying attention. And I burnt the optical isolators clean off the board. I mean, they smoked, and once you let the smoke out, you can't put it back in. So what I did, but the relays were still fine. These relays are pretty tough. So what I did is I took a Dremel and I chopped one of these relays off, just left this little bit of terminal strip and chopped it right off the board, and then chopped off the bad optical isolators. And then on the bottom, I just soldered right to the coil, which I believe was these 2 wires here, these 2 pins. So I just soldered wires directly to the coil. So it's not optically isolated, and I quite frankly don't care. It seems to work just fine. I have my big power supply here that I put on 12 volts. It's actually variable. I boosted it up to 14, ran that, and it seemed to do just fine. So 14 volts in, it creates 5 volts DC here, feeds the Arduino, and then the Arduino runs this relay just fine. So what I'll do in my car is I can take these 2 wires here. This is ground from the Arduino, and then signal in. And I'm using the internal pin resistor, so that way I don't have to have a resistor in here for an input. I'm going to run ground from the Arduino out to my float switch, back from the float switch in here, and then this is programmed with the Arduino is programmed with a 10-second delay. And I did that on this big guy here. You already saw that earlier. So I got a 10-second delay. If that float switch sends a signal for 10 seconds, the relay will close, sending 12 volt DC that I'm going to feed through the contacts of this relay out to my dash LED light. That way it will function as it should. The only issue only thing I can think of is I can't for the life of me remember if that float switch that's in the oil pan is normally open or normally closed. I think it's normally open. I could be wrong. I probably am. But I just don't remember one way or the other. I know I wired the stupid thing up, and I just can't remember which way it is. And I can't get this closed because I'm holding a camera. So what I did, and it does close with it in there. What I did is I just took the end of this container and I chopped it open so I can get access to that USB port to reprogram it. I'm going to try it assuming that it's normally open. And if that doesn't work, it's not that big of a deal. I've got the USB port there. I can just plug the laptop in and I can flip the low to high in the program and make it so it would work off normally closed. Not a big deal. So if it doesn't work this way, I'll have to flip that in the program. So I'm going to get this closed because, like I said, I can't do it with one hand. And I'm just going to wrap the whole thing in tape. So it'll be a black box with some wire sticking out of it. And then I'm going to wire it up in my dash and see what happens. Okay, so back to my little oil light dilemma here. Like I showed earlier in this video, I had the Arduino program made, kind of put together in that plastic enclosure. What I did off camera, and I'm just kind of making these clips and then I'm going to edit them together into one long video. But what I did off camera is I put all the pieces that you saw in that box, hot glue, just filled it with hot glue. And other than the USB, the little USB end I left exposed so that way I could tweak the program any way I needed to. And then I wrapped it in black electrical tape and shoved it in my dash. Now what I did, this is the dash panel that I made for the car, and I have it all on these weather pack plugs so that way I can unplug my entire gauge assembly and pop it out. I have one weather pack here and I have another one in here, and the weather pack includes all the wiring for my warning lights, turn signals. The only thing that's not on it is the GPS signal for the speedometer. It's kind of on its own deal, but other than that, there's a weather pack plug there. So you're not gonna be able to see it, but right up in here is where I was able to shove that plastic box with the Arduino and that relay in it, okay? So I have power going through that relay inside the box. Right now I have the float switch. I'm sending 5-volt DC. No, I take that back. I'm not. I'm sending ground from the Arduino out to the float switch and back to one of my input pins, and I'm using an internal pull-up resistor on the Arduino. If you guys are Arduino fans, then you know what that means. That way, I don't need a separate resistor in there on the input. I'm using the internal pull-up. So yeah, I'm sending ground. And then I have 5-volt DC coming out of an output going to a 5-volt relay, and that relay sends 12 volts to the oil light. So if right here is the warning light, this one right here for the oil. If I turn that on, I turn my ignition on, you see the battery one turns on like it should, but we set here for 10 seconds and the light won't turn on. I'm going to take another video where I'm out driving it, and we're going to do an actual drive test to make sure that, hard deceleration down hills and things like that, you don't see it turn on. And actually all you can see, if you see this kind of red light back in there, that's the Arduino. That's the box, and just the back side of that little enclosure right here is clear. And you can see that's where it's coming from. So, yep, my light is definitely not on. Now, one thing I wanted to point out that I found out in this, the float switch that GM used is normally open. And I wasn't sure whenever I started making this, so what I had to do, I had programmed it as if it was normally closed, and I had to go back in and change the program a little bit. I just had to change the, low to high or high to low, whichever way that worked. So with it normally open, technically, because there's supposed to be oil in the engine, obviously, it would be normally open, held, closed float switch. So basically, if I lose that ground for 10 seconds, meaning the switch opens for 10 seconds, then the light would come on. So that way it'll stop blinking in my face. And you know what? You may ask yourself, why in the world did this guy spend all this time programming an Arduino and spending all this time just to stop an LED from flickering on his dash? And you know what? I don't have a good answer for that, other than, man, it drove me nuts. It really did. I like things to work, especially electronics that I can make work, and I have the ability to tune and tweak and program. So it just drove me nuts. Couple things in this dash yet that still aren't hooked up. I do have a check engine light on here. Now, I don't have a factory computer. I'm running a Holley Terminator X. So I'm going to use this on an output from the Holley to monitor things like oil pressure, fuel pressure, knock sensor counts, all kinds of things. And if any one of those things are out of order, it's going to make that light turn on. And I may have an Arduino have something to do with that too, simply because the Holley will output as soon as any of those things happen, but it doesn't have any way to latch. It doesn't have a latch on that output. I can have that signal come from the Holley into an Arduino and have that latch that output until the key were cycled off and on again. That'd be super easy. So that might be something else. I might be sticking another one in here, or I very well may just tie into the one that's already there, being that, you can buy, like, I swear the company that makes these Chinese knockoff Arduinos is the same company that makes ramen noodles. You can get like 50 of them for a song and a dance. So maybe I'll just use another one because reasons. But anyway, I'll throw in a little clip here of me driving the car, trying to get it to mess up. And then this thing will be over. Okay, test to see if the light comes back on. So far, so good. Even under hard braking downhill, nothing. So I'd say our little project was a success.